Hi, in this video I will show you how we can create AWS VPC Elasticsearch with using Terraform and doing the CICD task via GitHub Actions. As you see in a screen, so this is a pictorial overview of my demo. I have an GitHub account which contains which hosts my GitHub repo where I have hosting my GitHub Actions as well. Right, so that's the reason I have kept the GitHub logo as a big one where it will be hosting my Terraform file and also the GitHub Actions definitions as well. Okay, so in the right side, as you see, I have the AWS account. Okay, where actually I will be creating a VPC. In that VPC I will be hosting this Elasticsearch service. Okay, so and at the end you might know that the Elastic service is also provides a Kibana a tool which is an analytics and a kind of a Power BI kind of solution. Okay, so this is what the complete demo is all about. So the pipeline is looks like this. I have a Visual Studio Code where I have cloned my GitHub repo. That GitHub repo where I will be creating I will be writing an infrastructure as a code in Terraform, which will spin off the complete VPC stack, VPC Elasticsearch stack in the AWS account. And I will be doing the CI/CD task via GitHub Actions. At the end, when I complete my pipeline, I would be having an VPC Elasticsearch cluster running in the AWS account. Right, once the cluster is been running, you know that from the cluster we can access the Kibana service, which is a monitoring kind of tool, which is a dashboard and monitoring kind of tool, which is beyond that though. I would again leverage, I would again recommend you to explore on your own. Right, so here, so what I do is, so let me start from the scratch. So let me open here. So here I have the Visual Studio Code as I explained. I have cloned the repo from my GitHub account. So this is my GitHub repo name. Yeah, it contains so as you see here, it contains these many folders. One is the .github, which is hosting the GitHub Actions definitions, and I have the two Terraform file. One is the main.terraform file, other one is the create elasticsearch.terraform file. Okay, so as the name says, main.terraform file contains the backend Terraform information, nothing but where actually the Terraform state file will be hosting. And also I have the one more file, that is create elasticsearch. Okay, this is the whole and soul of file which contains end-to-end definition about how we can create the VPC based Elasticsearch stack in the AWS account. Okay, yeah, so this is the file which I will be going through line by line now. Yeah, and finally I would run the same script. I have already run the same script, but I will show you, I will walk you through the logs of the Terraform plan and Terraform apply stage. Yeah, and finally I will show you that how we can access the Kibana tool, which is hosted or which is pointing to our Elasticsearch engine. Okay. So as I explained, so this is the main.terraform file, and this is the create elasticsearch.terraform file. Okay. And one more thing. So under the GitHub .github /workflow folder, I have terraform.plan and terraform.apply files. Okay, so as the name says, these are being targeted to do the same jobs. One is terraform apply, which is actually a spin of the services in the AWS account, and terraform plan is nothing but, as it says, it will just create a draft of the infrastructure before you run the terraform apply. Yeah, so again, so to know more about in depth about these files and these structures, please do watch my previous videos where I have explained everything from the scratch. Okay, so in this demo I will focus on creating the Elasticsearch stack in the AWS account. Okay, so as you know that the Elasticsearch, okay, Elasticsearch is a AWS is open source tool, and AWS manages it. Okay, so that's the reason name is AWS Elasticsearch service. Okay, so this service is mainly used for as an search engine or as an analytics tool. Okay, so and majorly this service is used for log analytics purpose or a real-time application monitoring purpose, or you can use it for clickstream monitoring purpose as well. Okay, so these are the three main use cases of this Elasticsearch engine. Okay, so as you saw, this is the complete search engine, but from the back end it also exposes one more great tool, that is Kibana tool, which from where you can do the all required kinds of analytics. It can be image level analytics, it can be log level analytics. Okay, so kind of a tool will be exposed by Elasticsearch. Okay, now, so in this special case, why this is special cases, as you know that the if you spin up a Elasticsearch service in the AWS account. Okay, let me go to the AWS account. So this is my AWS account where where I have already spin up the service, which I will show you, explain you step by step. So this service, either you can spin up in the directly into the public AWS account, or you can make that service encapsulated within a VPC. Nothing but that service won't be accessible outside the internet. Okay, so that's the specialty of the VPC Elasticsearch engine. Okay, so here I have made my Elasticsearch service to sit in a VPC, so that the cluster will is encapsulated within that VPC, and it is not accessible outside the world. Okay, so that's the main aim of this demo. So as I said, like it's a VPC Elasticsearch engine, so we have to create a VPC first and do the required configurations around the VPC, then create the Elasticsearch engine. Okay, so how we can do that, let me quickly walk you through this code completely. So from the first, okay, anyways, I will keep this file in a repo and you can use it later as well. So here I'm storing a reason variable which I need down while doing the rest Terraform code. Okay, so here variable is region, which where I'm storing the US East region, and the locals. Okay, in the local is nothing but local variables where I'm storing the ELK domain name, nothing but my Elasticsearch domain name. Okay, which I'm creating dynamically. Yeah, so this is my local variable. Then I'm retrieving my region data, that is the current region data, and caller identity. Okay, so nothing but caller identity. AWS caller identity is nothing but the your current profile data. Okay, that will be retrieved there, which we will be using down. Okay, so now first one, again we are getting the availability zone data as well. So data, wherever you see the type data, and this is the resource type, then nothing but you are retrieving the data of the respective resource types. Okay, and the next one, let's go to the main one where I'm creating the VPC. As you see here, so this is a chunk of code which creates a VPC in the AWS account. Okay, so here resource is again a resource, it's a resource, then it's AWS VPC. This is the variable. Inside this flower bracket block, we are giving the parameters like what is our CIDR block, enable the DNS hostname equal to true, and adding it tags. Okay, yeah. So this is of my VPC configurations. Now I'm dividing this VPC into multiple subnets. Okay, which I need for some main reasons. One, I will be creating a 3 public subnets and 3 private subnets. Okay, in private subnet I will be hosting my Elasticsearch engine or Elasticsearch cluster, and in the public, where this public will be exposed to the internet, where users can host an EC2 instance, and from there the Elasticsearch or nothing but Kibana tool can be accessed. Okay, so that's the reason I'm creating 3 AWS subnets, which is public in my case. Okay, so this is the one code. It's here, it is a resource, and the resource type is AWS underscore subnet, and the name is variable name is public underscore one. Inside this flower bucket, we are giving the reference of VPC ID, nothing but where actually it is sitting, right? It's referring to the above VPC, which I have explained you just now. Yeah. And then the CIDR block. The CIDR block is nothing but it will be a sub chunk of this. So if we divide this /16 CIDR into multiple ranges, so that it becomes a subnets. Okay, so that's the reason I'm just dividing that /16 into in the format of something some small chunks. Okay, which I will show you later in the dashboard, in the AWS dashboard. Okay, then availability zones. Okay, I'm just pointing to the respective availability zones. Okay, as I show, like, so I'm keeping the one subnet in a particular one availability zone. So that's the reason 3 subnets are being created, one pointing to one availability zones. Okay, so this is pointing to one availability zone 1. Then I'm mapping the public IP on launch. Okay, nothing but, so public IP can be spinned up in this subnet. Okay, that's the reason it's called as a public subnet. Okay, similarly there are the 2 other copies of public subnets. That's the reason code is looks similar. Yeah, so here the name is just name changes to underscore pub underscore 2. CIDR also is a next chunk of the same CIDR block, and this also points to the same VPC. And the CIDR block zone, if you see here, this has been sitting in a next availability zone, and it is also mapping to public IP address on launch. Yeah, so next one, similarly again a copy of same subnet is being created and name is given as a public 3. Yeah, so this is the code. Now let's go to the next one. So next I'm creating the internet gateway. So internet gateway is required to come into, okay. So this internet gateway service is required for us to access the our um, to access the bastion host which will be sitting in the VPC, okay. So here I'm creating the AWS Internet Gateway service. It's again resource. This is the resource type. It is AWS underscore Internet underscore Gateway, and the variable is demo. Inside this flower bucket block, we're giving the VPC ID and the tag name. Okay. Then, so as you know that we also need a route table right now. So that's the reason one more resource type is being created, route table. Okay. Why do we need a route table? So that the to make the routing, right, nothing but the traffic which is originates from the internet to be redirected to internet gateway. So that's the reason we need a route table, right? A route table is nothing but which contains routes which will have the definition of a route, like saying like from which source to which destination it has to pass, the network traffic has to pass, right? So that's the reason that we have the route table, and this is the block which creates a route table for us in this requirement. So this is the resource type, that is AWS underscore route underscore table, and we have the parameter. This is I will always call this as a variable of a resource. Okay. So inside this flower bucket block, we are giving the VPC ID. Then we are defining our route of the table, where the CIDR block is nothing but internet. This is 00 is nothing but internet, and the gateway ID is, this is the gateway ID. Yeah. And this is a general tag which I'm attaching to the route table. Finally, what we are doing, so we are associating the route table to our subnets. Okay, that's where this code does all about. Okay, first one, I'm associating the route table, above created route table, to the public one subnet, and this is where the code is does all about. It's a resource, and the resource type is AWS underscore route underscore table underscore association. This is the variable, and the subnet ID is nothing but pointing to the public one ID. Then the route table ID is nothing but it is pointing to the above route table ID. Yeah. Then similarly, the same other two task is done to make association of public to subnet with the route table. Okay, so this is to associate the public to subnet with the route table. Similarly, this code is meant to associate the public 3 subnet with the route table. Okay, this is the third task which we did. Let's go to the next one. As I explained, so these public subnets is required to interface with the internet. Now, since our Elasticsearch cluster is a private one, we need a subnet which is not exposed to the internet in general. Okay, so that's the reason I will be creating 3 more. Here we will be creating 3 more subnets, which I will call it as a private subnet, or just a noted one, just a simple name is being given. But yeah, anyways you can call it as a private subnet. Okay, so again the definition is same as we see in the above for public subnets. Again, it's a resource. Then the resource type is same as AWS underscore subnet. Noted underscore one is, this is a variable name. And inside this flower bucket block, we are giving the VPC, which is targeted to the same VPC. If you see the CIDR block, okay, I'm getting the smaller chunk of CIDR block here. Availability zone is again, right, as I mentioned, like I'm keeping one subnet in one availability zone. Okay, so that highly availability is being achieved. Okay, so that's the reason our first subnet is sitting in the first availability zone. Similarly, the 2 and 3 are also sitting in the availability zone 2 and 3. Okay, so that's the reason you see the same code but just pointing to the different availability zone. Yeah, similarly for subnet 3 as well. Okay, anyways, one more time reminder, I will be keeping this code in my repo, and I will be sharing this repo's link in my video summary. Okay, and then let's go to the next topic of the code, where I will be creating an elastic IP address, which I needed for further task. Okay, so that's the reason the elastic IP 3 elastic IP addresses have been created, where definition is something like this. It's a resource again. This is AWS underscore EIP is nothing but elastic IP address. This is the NAT variable, NAT gateway elastic IP address, because this I need this one for next job, that is to create the NAT gateway. Yeah. Similarly, I'm creating the elastic IP address 2, elastic IP address 3. Yeah, as you see, right, the definition is same, right? So now let's go to the next one. where we are creating the AWS NAT gateway, right? So let's me select this code. So this is the code chunk which creates a NAT gateway service, that is network address translation gateway service. This is resource AWS underscore NAT underscore gateway is a resource type. This is a variable, and inside this we are giving the parameter. One is the allocation ID, is nothing but NAT gateway elastic IP address which we created above, right? And as a sequential, it is pointing to the respective public subnets. Okay, so one elastic gateway one is pointing to the public subnet one. Similarly, I'm also doing the subnet for public subnet 2 is pointing to elastic IP address 2, and where the gateway 2 service, that is the NAT gateway 2 service, is created with using those references. Okay, similarly for 3 as well. And then let's go to the next one. Okay, similarly, as I explained, like how we created a route table for the public facing subnets. Similarly, for private facing subnet, we are also creating the route tables. Okay, so this is the definition, which looks same, but here the parameter changes. Okay, so let me make a note here. So this is again a resource, and the resource type is AWS underscore route underscore table, and this is the name is given as a noted one, nothing but private route table. Okay, which is attached to a route table which is attached to private subnets. Okay, in general. Then this is a VPC ID. This is a route definition where you see, right? So it's now since it's a private, it is pointing to NAT gateway. Okay, to do the network address translation, right? So this is a network theories, right? If you are sitting in a private environment where there is no public IP address, you need a network address translating service, network address, right? That's the reason we have the NAT gateway service. Yeah. Similarly, so this is the resource type which creates a route table for our private subnets, where NAT gateway service is been pointing to the respective NAT gateway services which we created above. And then here I'm giving the tags as well, right? Now let's go to the next one. Similarly, I'm creating the 3 copy of same services but pointing to the respective NAT gateway service. Yeah. Then let's go to the next one. Next one, similarly, I'm doing for the NAT gateway service 3, and it is pointing to NAT gateway service 3 as well. So here we are creating the route table of private version 3 pointing to the NAT gateway 3. Okay. Now, yeah, so it just a replica of the code one which I explained, but just the values are changing. Okay, that's the reason I'm going fast. So now let's go to the third point. Okay, the next point what we are doing, it's obvious. The next one what we are doing is we are associating the private subnet with the respective route tables. Okay, so that's what I'm doing here. This is again resource. This is the AWS route underscore table underscore association. Okay, that's where the association of route table and the subnet will be done here. Yeah, this is the variable inside this private uh, flower bracket. We are giving the subnet ID, which is nothing but our private subnet ID. Then the route table ID is pointing to the respective route table ID. Yeah. Similarly for the two association 2, where we are doing with the where we are associating the subnet private subnet 2 with the route table 2. Yeah, the next one, I'm creating a security group because I need this security group to be attached with it while creating the Elasticsearch service. Okay, so that's the reason this is a security group, right? This is a AWS security group which is getting created here now. It's a resource again. AWS underscore security underscore group is a resource type. This is a variable inside this flower bucket block. We are giving the parameter. One is the name of my security group, then the description, VPC ID, and I'm defining an ingress rule. Okay, the ingress rule contains port equal to 0, nothing but all, and the 2 port is nothing but all. Protocol is again all. Okay, so that's the reason. And here the source is pointing to the CIDR of my VPC network. Okay, so this is the rule which ties the inbound rule within the VPC. Okay, yeah. So now let me go to the next step of the code. So in the next step, what we are doing? The next step we are creating the AWS linked services. Okay, And here my linked service is nothing but ES, that is the Elasticsearch service. Okay, it's a resource, and the resource type is AWS underscore IAM underscore service underscore linked role. Nothing but this is a role which is linked to the service. Okay, because we need this role for making our service to run. Yeah, so that's the reason the service name is pointing to our Elasticsearch AWS.com service. Right. Finally, we are came here, and this is a big code which is actually creates Elasticsearch service. Yeah. So now I will quickly walk you through this code as well. This is very critical part of the code. Let's go one by one. As you see, right, so this is the resource. Again, Elasticsearch service is nothing but a resource in the AWS. That's the reason it's a resource, starts with resource, and the resource type is AWS underscore Elasticsearch underscore domain. Right, name is a bit different, so that's the reason each service instance is called as a Elasticsearch domain, and this is the variable. Then again, parameters inside this flower bucket block. One is a domain name. What is the instance name of our Elasticsearch engine? Then the Elasticsearch version, right? This is my Elasticsearch version. Then what is the cluster configurations? What are your cluster configurations? Data will be provided in this object. It's a cluster config is nothing but an object. Inside this, we are giving the key values parameters. Instance count, I'm keeping the instance count equal to 3. Instance type, which is I'm taking the minimum instance type, that is the starting type of instance types of Elasticsearch engine, that is rg6.large.elasticsearch. Zone awareness enabled equal to true. Zone awareness configurations availability zone count equal to 3. Yeah, so that's the reason. So availability zone count equal to 3, which is where I have given here. Now let's go to the next one, where we are configuring the VPC options. Okay, under the VPC option parameter object, we are giving the our subnet, where actually the Elasticsearch cluster is supposed to be hosted. And the subnet ID, which I'm pointing to, nothing but my private subnet IDs. The nated underscore 1, 2, 3 are nothing but my private subnet IDs. Okay, so that's the reason under the subnet ID arrays, I'm pointing those subnet ID IDs. Okay. Then the security group. The security group, as I explained, the security group which I have created above is being now pointed here, right, where the inbound rule is being targeted to my VPC only. That's the reason, to maintain the network traffic within the if any traffic coming or any traffic reaching to this Elasticsearch cluster should be originating from the same CIDR block. Okay, that's what the security group restricts all about. Okay. Then we are configuring the EBS options. Nothing but this is the storage type option. That is the EBS. I'm using the EBS storage type. That's the reason it's EBS enabled equal to true and volume size equal to 10. This is the minimum requirement for the development environment, whereas for production the size should be chosen according to the requirement. Then access policies. In the access policies is nothing but so once the Elasticsearch cluster is hosted, then from where you need to access the Kibana tool. That's what the access policy tells about. So here I'm just giving the definition, where the statement, under the statement, the action is nothing but Elasticsearch star. Principal is nothing but anybody. Effect is allow, and here Elasticsearch ARN is being targeted here. Okay, that's the reason, nothing but it's access policy, mean nothing but from where you can access the Elasticsearch engine's Kibana tool. Okay, then let's go to the next one. Then the snapshot options. Okay, so under the snapshot options, which I have taken equal to 23. Okay, this is being given from the Terraform side, which will configure the Elasticsearch cluster snapshot. Okay, so this is automated snapshot, starts at hour 23, nothing but at every 11 p.m. of the day the snapshot will be taken. Then tags, I'm just adding the tags. Okay, finally I'm just printing out the required outputs. One is what is the endpoint of my Elasticsearch domain, nothing but my cluster, and the Kibana endpoint, nothing but once the cluster is being hosted, the AWS provides a built-in service, built-in endpoint of a Kibana tool. Okay, pointing to that particular cluster. So this is the output which gives that particular endpoint URL. Okay, so this is complete code walkthrough, which is bigger though. I have already ran this code in my environment. Since it takes more than 15 minutes to spin up the complete cluster, I have already pre-ran it. That's the reason I will let me quickly walk you through the logs, and I will show you the resource being created in my tool. Okay, so the code which I run is exactly same, even line by line exactly same. So I have already ran on my AWS account. So let me show you that. First, when I did my code, this is nothing but when I did the synchronization, this code to my upstream branch, then my Terraform plan GitHub action has been invoked. So now let me quickly walk you through the logs of the ES cluster, nothing but Elasticsearch cluster. So here, so the Terraform plan has these many outputs. So what actually it does is it will actually summarize you like what are all the resources it's going to create in the AWS account. Okay, so there are huge list of services which got created, which is supposed to create it. That's what the summary says about. And let me slowly walk down. Yeah, so these plus mark is nothing but for adding the respective resources. For example, a route table, right? Because we have defined it. Similarly, let's go down and see the summary, what the summary says. In summary, if you see here, the plan is says that it's going to add 26 resources, 0 changes and 0 destroy. Okay, so that's what we want because we have gone through the logs. So finally what I did is I did my code merges to my main branches. Then finally I made to run my command, that is Terraform apply, which actually runs the Terraform code to spin up the Elasticsearch stack in the AWS account. So the logs of the Terraform apply code is something like this, which is big. Okay, as you see here, it has taken 11.47 seconds, nothing but almost 12 minutes to spin up the complete cluster. So this is what log says. What does it? It says is it's just a replica of the your Terraform plan, and whatever been mentioned in the Terraform plan, the same actions will be performed here if everything allows it. Okay. Now let me slowly move down so that you can have a glance at these logs. You can try in your environment. Okay. So again, to know more about around this Terraform GitHub actions, Terraform and the GitHub actions related configurations, do watch my previous videos where I have explained in regards to these configurations and all. Okay. Now I will come down to the summary. Let's see what the summary says all about. Here you go, right? So it has successfully created the total services that are total 26 resources are being spinned up, 0 changes and 0 rest. Okay, this was my fresh AWS account. That's the reason it has shown only 26 resources, because in this demo I'm targeting only the VPC Elasticsearch engine. Okay, Elasticsearch cluster. Okay. So once the Terraform apply action has been successfully completed, now I will show you the resources are being created. Okay, now um, I'm in Elasticsearch service dashboard. So this is my AWS account. I'm now again refreshing back to the Elasticsearch dashboard. This is Amazon Elasticsearch service dashboard. Here it has only one cluster. So this is the cluster which we created via GitHub Actions. Okay, that is Terraform plan and Terraform apply. As it says, the endpoint is VPC. Nothing but this cluster endpoint is accessible within the VPC. Nothing but encapsulated within the a private environment. Okay, it is not at a, no, it is not able. It is you cannot access this endpoint in the internet. Okay, that's what it means. So it contains the version is equal to 7.10, search documents equal to 7, Elasticsearch health equal to green, right? So these are the data, and the status is active. Now let me go here. So this is the complete definition of my Elasticsearch cluster. Health instance, health, then VPC auto tune. So if you go to the VPC, so this is where my Elastic cluster is now sitting, right? There are 3 subnets which are private subnets, and each subnets are pointed to the respective availability zones. So that's where my Elasticsearch cluster is hosted now, and this is the role it consumes for doing its operation. Then it has this is the security group, and this is where the VPC, where actually the EKS this Elasticsearch cluster is been encapsulated to, and from where you can access. Okay, then attunes, logs, upgrade history, packages, etc., etc. are the properties of this one. Okay. Now, before I go to this one, so let me show you that. So as I said, so this is the endpoint of your AKS cluster. Okay, this is the endpoint. This is a VPC endpoint of your Elasticsearch cluster. Okay, and this is the Kibana endpoint. Nothing but from where you can access the Kibana tool. Okay. Now, if I access this Kibana tool from the internet, okay, this my laptop is internet. Okay, I'm not in any VPC EC2 instance. Okay, so since this is an internet, let's see what response it does gives. Okay, it will end up with error. It does not, it will not access. Okay, it will not be able to access this Kibana tool because it's internet, because that's the reason we have encapsulated this Elasticsearch within a VPC. So that's the reason what we need to do is we need to spin up an EC2 instance into the public subnet that we created while creating the resources, and from that EC2 instance, from that machine, you should be able to access that Elasticsearch cluster endpoint, that is Kibana tool. Okay, so that's the reason what I did is I spun up an EC2 instance, that is Windows server, pointing to my public IP address. Okay, pointing to my public subnet. Okay, if I go to the subnets, so this is a VPC and this is my T2 micro Windows server. So this is T2 micro Windows servers from where I will be accessing the Kibana tool. Okay, as you see here, so let me go back. So it's still running. It will end up with error. So while it ends up with error, let me quickly walk you through the other properties of the tool. Right, we have created a Windows server. Now let me go to the VPC. If I go to the VPC, I should show you the 6 subnets which we created. So this is my VPC. Now let me go to the subnets. So we have 6 subnets here. And if I show you slide a bit to the right, if you see the assignable scope, some of having assignable scope public IP address. Okay, so wherever the public IP addresses are there are nothing but public subnets. This one, and this one are the public subnets from where you can access the VPC. So from where you can access the VPC Elasticsearch cluster. Whereas the other top three are the subnets where actually the Elasticsearch is being hosted now, as of now. Okay, so that's the reason what I did is I hosted my EC2 instance in here. Okay, let me point out that subnet. So this is, let me see it here. So this is ending with 3A67. Right, my EC2 instance has been hosted here, from where by logging into that particular EC2 instance I should be able to access the Elasticsearch cluster Kibana tool. Okay, so here you go, the site is not reachable. Okay, nothing but that particular cluster is not reachable from the internet. Okay, that's what we wanted to achieve and we have achieved it. Now the one more step is left. What is that is we have to be in the VPC environment where actually the cluster has been hosted, and from there we should be able to access the tool. Okay, that's what the target is all about. Now let me go to so this is my EC2 instance which I have already created, and one more thing to tell you here is you should be accessing that Kibana tool from the Google Chrome only. Okay, it is not supporting the other environment. Okay, for your information. So that's the reason what I did is I'm inside this VC2 instance, and now let me load the endpoints. Okay, so first let me invoke this endpoint, that is VPC endpoint. It should give us the response. Okay, that is what expected. Okay, if I search here, it will throw this error. If I go here and invoke that endpoint, yeah, here you go. So this is my cluster name, and that's what it has given some response back. Okay, now let me actually invoke the Kibana tool endpoints. Okay, which is throwing error here. So let me copy that endpoint, and yeah, I will be invoking this Kibana tool from this. Yeah, so here you go, it is successfully loading it. Okay, so this is visualize and analyze your data. That's what the Kibana tool is done. Okay, so that's it. I have successfully shown you like how you can spin up an VPC Elasticsearch cluster using Terraform, and doing the CICD via GitHub Actions, and how we can restrict the accessibility, nothing but how we can restrict the endpoint of the Elasticsearch cluster within the VPC, and also restricting the access from the internet, okay, via this demo. Yeah. So that's all. I have successfully shown you the required demo to be shown here. Lastly, kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot.